In this video, we're going to have a look at the misuse of statistics. So you'll remember from a few lessons ago that statistics is the science of collecting and analysing data gathered about a population. Now, a population, we said, was the entire group being studied. So, for example, we could say a population in Lucan Community College is the first years. We also said then that usually when we do surveys, what we tend to do is we take a sample of the population, and a sample is just a smaller group of that population. So, for example, you could pick at random 30 first years. The first years are the population, the 30 students that you picked out are the sample. We said it's really important that when you do a survey, so when you gather information about a population, that your sample is representative of that population, so that there's a small it's a small group, but that it represents everybody in that first year. So it should be representative, or the other word we said it could be is unbiased. So if it was biased, if it was the opposite here, that would be, for example, if I was to look at the first years of the population and just pick 30 girls, that wouldn't be representative of all the first years because I've excluded the boys. Or, for example, if I've took 30 of class O'Riordan, that would be biased as well because I didn't take from the entire first year population, I just stuck with O'Riordan. You see statistics every day, like in the news, or sometimes when you're shopping online, you're asked to do surveys. So they're in our life every single day, but sometimes they can be slightly misleading. Now, it can just be an accident, it can just be somebody's added something wrong, or there's a calculation error, but sometimes they can be maybe falsified, so they can be made up, or they could be exaggerated to purposely mislead people, or just to kind of tell the wrong story, or tell a story that maybe suits just one side and leaves out the other side's story. Now, one way you think about doing that would be if we were to want to survey something about the first year, to say I wanted to know how long did the average first year spend on their homework. If I was to say take from that population of first years just 30 girls as my sample, that would be biased, and that would be slightly misleading on purpose because I excluded the boys. Now, if I knew I was doing that, that would be misleading. But if by accident I just never thought about it and I said, oh, I'm just going to pick 30 girls, I could have done it. I could have just not understood how to correctly hold a survey, to conduct a survey. But there is a difference, and we have to know when sometimes maybe something is just accidental or when it's misleading. Okay, so like I said, the first time is just a mathematical error, so we've just made some mistake maybe in adding, or we've done some calculation on the calculator wrong. So we have two examples here. So the Irish Times prints an article in September saying that 72% of students passed their maths exam and that 31% of students failed their maths exam. So we have there two statistics, and we're going to see what's the error here. So pause the video, take a minute, see can you figure out yourself what is wrong with those two statistics. Okay, so if we have a little look at the numbers, we have 72% of the students passed and that 31% failed. Now, for example, if this survey was based on all the students who did their Leaving Cert in a certain year, say there was 60,000 students that did their Leaving Cert, they are 100%, that population should add up to 100%. So if we're to look here and say, okay, so 72% of the population passed and 31% failed, what should I get as my total? And I always say to you, like, what's the most you can get in a test? What's the highest percentage you can get? And it's 100%. And it's the same here when you do any calculation about your population, your two answers should add up to 100%. So if I do this here, if I say 72 plus 31, I come out with 103%. So straight away you can see there's an issue with one of those figures. One of them must be incorrect because I'm 3% over the 100%. So somebody's either made a mistake, they've written something down wrong, but that is then a misleading statistic. So the second one that we have then, 100 people are surveyed at a Dunnes Stores supermarket. They are asked if they prefer to shop in Dunnes or Aldi. So 54 say they prefer Dunnes and 44 say they prefer Aldi. Again, you can pause the video and see, can you figure out what might be wrong with those statistics there? Okay, so it says that 54 prefer Dunnes and 44 prefer Aldi, and in total they surveyed 100 people. Now, when you're doing a survey, it's really important that the number of people that you survey, so your sample size, it should add up. So when you break it down to the 54 here that said they like Dunnes and 44 that said they like Aldi, that should come up to 100. Now, if I was to add 54 plus 44, I wouldn't get 100. I'd get 98. So there's an error there. Now, either they've done something wrong in the surveys, they've counted them wrong, or they've written down the wrong number, so maybe more people like Jones or more people like Aldi, or maybe there was 2 people that said they like another supermarket, that said they prefer Lidl. Now that should have been included if that was the situation, or it could just be that they added something wrong. So that's the first way that you can have a misleading statistic, and it can just be an error in the calculation. Okay, so the other then way that statistics can be misleading is that they can just be falsified, maybe made up, or they could be represented inaccurately on a graph so that it shows a better picture or a worse picture depending on what way you want to tell your story. So for example, just one that's not on the screen, if for example I wanted to find out what student subjects was their favourite, and I decided I was going to go to Maths Fun Club and survey the students there. If you think of the sample of students that I'm looking at, they're students who say they like maths, they're at the Maths Fun Club. So I have gone and I've used a biased sample. So that's one way that you can be misleading. You can choose people that have already said they like your product or that they like your subject, and you could survey them, which means you're more than likely going to get the answer that you want. Now here on the slide, you'll see I have 2 graphs, okay? They represent the exact same information. So this first one says that while Obama was president, more students got their high school diploma, so basically finished secondary school, than ever before. So if you look here in 2007, 2008, it said that 75% of students graduated. Then if you go to 2013, 2014, it says that 82% graduated from high school or secondary school. Now, if you look, that's only a 7% rise, which isn't that much. But if you look, this stack of books is really, really small, and then 82% is huge. It's like more than, if you look at it, it's actually more than double, which that's not the truth. If you look at the actual statistics, only 7% more. Now, also, if you look at this, I know they have little books to make it look more appealing, but this is just basically a bar chart. So there's small bars here that represent the different years and what percent of students graduated. If you were to actually draw this on a bar chart, which is what I've done down here, we said that when we were drawing our bar charts, they should always start at what? At 0. So this axis going straight up, this vertical axis, should start at 0 and then go up in equal increments. But if you look here, this isn't going up in equal increments, because here we have, say, there's like 5 books there representing 75%. There's no way that then this stack of books here has gone up in equal increments. So here we can see that it goes from 0 to 15, 15 to 30, so it's 15 the whole way up. So if we look here, so while the graph is still showing, yes, more students are earning their high school diploma than ever before, you can see here it's at 75 and it is increasing to 82%. It doesn't look as dramatic as this one up here. So this one would make you believe there's been a huge increase in the number of graduates, and this one here shows you it's actually only quite a small increase over that period of time. So the second one down here, you wish to survey the average heights of 13-year-olds in your school, you choose 30 girls. Why would your results be misleading? So have a think for a second, think about who I've chosen to survey. So I've picked 30 girls, but think about what I want to show. I want to show the average height of 13-year-olds in your school. I didn't say the average height of 13-year-old girls, I just said 13-year-olds. So who have I forgotten about? I've forgotten about the boys. So that's again, it's a biased sample that's not going to be representative of all all 13-year-old heights. So I needed to pick a random selection of boys and girls.